in this video, we're going to talk about moments. And we're going to talk about some of the concepts. What is a moment? Some of the units and things like that. So the moment is, you might know the concept of a moment as a torque. So it's basically the force creating a rotation or creating an angular acceleration. So if we were in dynamics, we'll talk about angular acceleration. But in the case of statics, we're going to be talking about a rigid body trying to rotate. Let me give you an example. Let's say that we have a beam that is connected to a wall. So let's say that's the wall, right? And the classic example is a beam that will be connected to that wall. And at the end of that beam, we might have a force F. So what happens is that this force is going to try to make this beam not only displace, but also rotate, right? Rotate. So if we take, for example, this point A, we're going to say that that force F can create a moment about that point A. All right, so that's the classic example. Units for moments are going to be units of force times distance. So for example, we might have pounds, feet, we might have kilonewtons meter as two examples of those units, right? And the way to calculate this, we're gonna see that there are two ways in which we can calculate those moments. We can calculate them using vectors, the moment about a point can be calculated as following. We can say that the moment is going to be equal to a position vector cross my force vector. All right, so what this force vector, I guess, is clear, right? That will be, in this problem, will be equivalent to this force vector, right? It's this the vector describing the force. The position vector, not so clear. Well, let's define what that r is. That r is a vector that goes from the point of interest to anywhere in the line of action of that force. So that can be my r, right? So it's a position vector from the point of interest to anywhere in the line of action of the force. All right, so what is the line of action of the force? Well, this is the line of action of that force, right? So that position vector can be anywhere in that line. So it can go from A to this point over here, but it can also go from A, let's say over here. That will be another valid position vector, and the value of the moment that is calculated will be exactly the same. Okay. All right, so that is using vectors, right? Is a cross product of the position vector cross your force vector. If we want to use scalar analysis, okay, scalar analysis. So and this again is to define the moment about a point And in particular, this is useful for 2D, okay? If you do 3D, my recommendation is to do the vector analysis. If you do 2D, you can do the scalar analysis, and that works okay. That works relatively okay. If you do 2D, you can also do the vector analysis, and that works as well. All right, so how do I do this scalar analysis? So the moment is going to be defined, right? In this case, I'm gonna only do the magnitude of that moment, right? The magnitude of that moment. So not really a vector, but just the magnitude is equal to the force, the magnitude of the force. It doesn't have the arrow on top of it, so magnitude of the force, put it this way, times a perpendicular distance. Okay, so that's the magnitudes. What do I mean with that perpendicular distance? Well, that is, so this is a perpendicular. Okay, so if we go back over here on the top, the perpendicular distance is the distance, right? This distance that makes a right angle with the force. So in this particular case, this will be D. Now you cannot use other distances. It has to be this perpendicular distance. So again, we have our vector analysis, which is the cross product R cross F. In this one, I just do the cross product. I don't have to think about anything else. The scalar analysis, you can find the magnitude of that moment. And now if you want to define whether or not is positive or negative, what I mean by that is, since this is for 2D analysis, we want to define whether or not the vector is coming out of the page or into the page. For that, we need to use the right-hand rule. Use the right-hand rule. So for the sign, so use the sign, use the right-hand rule to decide the sign of the moment. Okay, sign of the moment. All right, how do I do that in the example that we had above? Well, in this particular case, if I think about A as a hinge, and I think about this being like a door, let's say, that is being pushed with this force, that's going to make this door rotate in this direction. And if I use my right-hand rule in this direction, is going to be a negative moment. So for this particular example that we see over here, is going to be a negative moment. So to summarize, in terms of moments about a point, there are two vectors, right? We can use this vector analysis with the cross product, or we can use the scalar analysis when we have the magnitude of the force times the perpendicular distance. And again, this one is mostly for 2D problems. If you're using any 3D problems, I do recommend that you use the vector analysis.